Okay, everybody is here. So, just to recap, you need Neodesk. So everybody is a setup for Neodesk, or there is still issue? Okay, so because it's not because you run it once. You can run it twice. So you need to test again if it is running properly. Just before we start, I noticed that FSL is kind of slow the first time is running. So what we can do, so let's start also with Neodesk. So you open it, you remember. Ça marche? Yeah, so we will use it. Yeah. So I will ask people for FSLIs to everybody to open it. So you can, yeah, I'm gonna show how to open it, which is normally I should get. Okay.
Now we will try FSL.
Yeah, remember you click on the Neodesk app here. Yeah, much faster because the first time you run FSL, you have a lot of packages from Python, and the first time is a nightmare.
These packages are common for every version of FSL.
Yeah, I think it's matplotlib. Matplotlib. Okay. Can I get that? Okay. So when you're on Neodesk, you open you go to Neodesk and you go to functional imaging, and you take the last version of FSL, the 16 here.
You can take this guy also, JUI.
Yeah, either. But normally when you do that, you have a shell. Technical support. I will see, maybe. From the back. What? Okay. Thank you, Michel. And you type FSLize in the new shell. So if you open a shell, by default, it will not load any FSL software. So Neodesk is using module, and so it loads what you need at the beginning. So for example, in a new shell, so let me put that big. Zoom in again. Is it enough like that? No, maybe more. Okay. So if you want to run FSL from a new shell, you do module load FSL. And like that, you will have all the commands from FSL. So you can do that like that, so using module, or you go to the menu here, and as I did before, functional imaging, you run it, where is it? FSL, you select the one you want, the recent one, and it runs, it opens a new shell with everything set up. So, and here you type FSLize. Let me put in big again. Because I noticed that the first time you run FSL, it needs to unpack some packages from Python, and it takes a little bit of time. So it's why it's better to. Okay, so you do that and you wait. So during this time, let's put that here. So everybody has run FSLize, okay? So let's go back to, okay, and then. So when we have FSL, we will start to work on some fMRI data. Let me see. Oh, you cannot see it on. Oh shit. Why is doing that? Okay, so I cannot open it. Okay. Okay. So what I'm using today, quiet, please. So today I will use some tutorials that have been done by Andy, which is a guy who is doing a very great job doing tutorials. So there is Andy's brain book, which is a blog, or it's a website where you can find all the tutorial I'm gonna show today. So if you type Andy's brain book, you will go to this website. I think Michel sent you an email. Let me remove the sound. Michel has sent you a link with GitHub, and I think I have all the instruction, and I think the website is indicated on this page, on this fMRI tutorial GitHub page. The reason for that is because it's really good, so you can follow, and these tutorials, you can go back to this all the instructions. It has a lot of details, so some of them I will not go, as I say, I will not go to the theory of fMRI. I will be more on the practical side of it, so we will try to practice to preprocess and analyze data. But at least you have the instruction and the resources where you can go to get information from it. So if I go there, okay, so this is what we will use mainly. So there is a part which is a short course with FSL, and we will use mainly all the instruction in it. Okay. So what we will do, we will download data first. After we will pre-process some of the functional data we got, and we will do some statistical analysis. So we will do first level analysis. We will not do second level because it will take time to download all the data, and it can take much more time. So what we will do instead, so after the first level, we will do some functionectome analysis. And at the end, if we have time and if we want, we can do some cognitivity analysis, but just to scratch the surface of it, okay? So again, very basic stuff. Okay, so that is what I wanted to say, I think. Okay. So before we download the data, so what we will use a task called the flanker task. So let's imagine you are a researcher, you want to test or to research cognitive control, for which the definition is the ability to ignore irrelevant stimuli. So you use the flanker task is a very standard task where you can see there is some example here. So what you need to, you have in the scanner, you have two buttons, one on the left, one on the right, and you need to press the left when the middle arrow is pointing on the left, and you need to point on the right when the middle arrow is pointing on the right. Very simple. What is not so simple is that you have other information showing contradictory direction. So here is a congruent situation where you have all the arrows going in the same direction, and you have incongruent stimuli where you have all the other arrows pointing in the other direction. So pretty simple task. So what we can do, if you go to the website here, so this is a reminder of the task. There is, where is it? So yes, if you can open on your computer the web page of the on this brain book. And if you go to this menu here, and you go to overview of the flanker task here, I think I saw somewhere there's a link, if I can see it. So if you click on here, just to show you and to practice a little bit the task, it's a way of doing the task outside of the scanner. So we can practice, each of you can practice the task. So here's the task. You press the fastest you can. Everybody's on this web page. You didn't find it, or did you find it? So it's here on this page, fMRI tutorial, overview of the flanker task. And if you go below the figure, there is a link here. No, it's okay. Okay. So it's, yeah, you have how many? Yeah, 20 rounds. So. So do you notice something? Doing there is a lag. Okay, so that is not okay. So I didn't. So maybe you are using the browser in your desk. Are you using? No, it's on. Okay, so this is your computer. It's not my fault. So what is the easiest? The congruent or incongruent? Yeah, okay. So because you need to do kind of inhibition of your, so you saw the other arrows, so you need to do inhibition of what you see on the size of the main arrow. So what you will be interested in, so everybody has done it? Yeah? So overview of the flanker task, yes. So what you will do, let's first start. So to test this task on the fMRI, on the scanner, what you will do, you will experiment like this. So the screen in the scanner, and you ask the participant to look at the point, and after you have the different situation, and you repeat the different stimuli several times. You put some jitters to have kind of not the same time for all the stimuli. And you do that several times. So the reason for that is fMRI is pretty noisy, so you need to repeat the task to get the signal you want. And at the end, what you will do, you will do contrast. That means you will look at difference between incongruent stimuli versus congruent stimuli. So it's what we will try to do today. Okay. So that, okay, congruent. Okay. Now, so this QR code is the link Michel sent you, so you don't need the QR code. So this is all the instruction you need in the GitHub page. So if you go to this, so this is my GitHub account, and if you go on it, let me show you. So it's just, I put a bunch of command lines we will use for this tutorial. So don't hesitate to stop me if you are lost, if you don't understand, if you want to do some recap. So yeah, don't try to look at the command lines here because you will not see. So I can maybe increase the size, but everything should be on your computer on the link Michel sent you. So there is a Nodesk website, and after on the Brains book. And what we need here is to download the data. So as I described you this morning, you can go to OpenNeuro and get some open access data set. So we will use this data set. I don't know if I can go there, or maybe not on this one. They put the, yes. So if I go to open new on this data set. So yes, so if you go there, this is the flanker task. So as I said, everything is stored on this website. So there is a description of the task, what it has been used for, which kind of article and which kind of research. And here you have the data below, okay? So as I said this morning, everything is in a bid format. So you have the name of the dataset. So you have some README file where you can see all the description, dataset description, the participant also on it. We can increase the size a little bit. And as I say, there is everything is stored. Yeah, you have subjects 01, and inside this folder you have anatomical scan, and you have the functional here. Okay, so for precision, so as I said, when you scan the subjects, you put them in the scanner, they do the task. What they did here, they ran 2 sessions. So it's why you have 2 images. You have the first one, task number run 1, and you have the second one, run 2. Okay, and we will look at this TSV file later on. Okay, so I don't want you to download, so you can download them directly clicking on these but we are not gonna do that. So what we are gonna do, so now it's the part where you go to Neurodesk. So normally FSL eyes should be open now after a long time now. Okay, so we'll see what we can do. Yeah, there is a there is a link. I can show you again. So here, so there is a line called install dataset, not download, and below you have the website. Yeah, so what we are gonna do is to download the data with DataLad. So DataLad is a software which is pre-installed on Neurodesk. It's like a little bit, if people know about GitHub, it's like versioning. GitHub is done for versioning codes, for example. DataLad is designed to versioning data sets. Okay, so you can put your data, get your data. So it's a LAD, and it helps you to download and organize your data. So what I want to do is to so let's add that. Let's close that. I don't need that. So on your desk, okay. So now I have a FSL. Let's start a new one. So you open a shell. So for those who are not familiar with the shell, so it's why I asked you the question this morning. If you want to do a listing of what is inside the directory, you do ls, which gives you what is inside the directory. So in blue, you have the folder, and in gray, you have the files, okay? If you want to go to a folder, you do, for example, cd. Can you see it at the back? Yeah, is it enough or you want more bigger size again? I don't know how much I can do. I don't think it's increased. Yeah, a little bit. Okay. You wait, you leave the FSLIs going and it will open at the end. So, and if there is an issue, we will solve that. So for example, you go to work, which is a folder in your home directory. You do cd work. You go to work. Okay, so that if you want to know where you are, you do PWD, which I don't know what it means. Working directory. Yeah, print working directory. Okay, thank you. So it gives you where you are. So it tell me I am in home, Jovian, work. Okay. So perfect. So I will put my data here. So if you go back to the GitHub, there is a line called dataset, datalad, install, and the name of the dataset. Yeah. Okay. So you copy it and you paste it. Is it working? Ah, okay. So for some of you, the one on the cloud version, there is a trick. But the problem is I know the trick on Windows, but on Mac, normally you do Control Alt Tab, and it will open a menu where you can copy and paste stuff. So after running the datalad install, if you do ls, you will see a new folder, which is the name of the dataset, DS000102. So you do CD, and you go inside, you do ls, you will see that all the organization of the dataset is here. So you have all the files and the folder, but that doesn't mean the data are already here. They are not here. You have just the skeleton of the dataset. The folder are. So if you go to a folder, in fact, you will see some file. For example, if I go to sub01, if I can type it correctly. Let me type that. Yeah. Yeah, you have the folder ANAT, so you can go to ANAT. So you see that it appears like the files are here, but they are not here. Okay, just to be clear with that. So you have the skeleton of the data sets, but you don't have the data yet. Okay, so there is a second command line to type. So if you go back to let's go back. So the data set is here. Okay, so that are the different subfolder. So for example, let's say I want the subjects number 1. Okay. What I do is I type datalad get sub 01. Okay. So it will start, you will see that it's starting to download the data for this subject only. Okay. So let's see. So I'm not running it because I already done it, but I can do that for subject 5, let's say. You should see something like a progression showing you. So there is 1 anatomical scan and 2 functional scan per subject. So as you can see, it's already done. So now, getting back to FSL, let's look at the data. So normally you should have now FSL eyes open somewhere. Everybody set. So now the data are on our desks. So if you go to FSL, you do add from file. So we'll look at the, so you go to the folder. So let's look at the anatomical first. Yeah, so you will not see, let's, yeah, okay. Let's take, I think I took 5, okay. Yeah. So it should open your anatomical scan, okay. So for those who are not familiar with FSL, you can play a little bit on the And the contrast, so there is here, so the contrast is from 0 to something, so you can decrease this value. For example, let's put 1000 or even more, 500 should increase. Okay. Yeah, file, add from file. Yeah. To start. So everybody is okay with that? Yeah, file, add from file. It will open something and you go inside the data set and you select the subjects you downloaded. Okay. And you do open. Yeah, everybody said. So after you can, yeah, so you can change the contrast. So you can see that it's a brain, hopefully. So you have the three direction, the three incidences. So the sagittal, axial, and coronal, and you can move around. As you can see, this data set has been anonymized. It's why you don't see the face of the subject. It's not because it doesn't have a face. It's just so there is procedure to remove the face, because when you give access, so it's open access. Yeah, it's open access data set, and so yes, people can reconstruct the face. It can be non-anonymous, so it's better to do that. So you don't have the face, but it doesn't matter because we are interested in the brain, not at the face. Something you can notice is below here. So you have different numbers here. So that is for the x axis, the y axis, and the z axis. So if I go up, this number should increase. If I go left or right, so this is the x direction, so this number should move. I don't know if you see where I'm pointing. No, this is a native space. So because now, yeah, just so that is you have two numbers, two columns of numbers, the second one and the first one. If your image was in the MNI space, that should be the MNI coordinates. Okay. So if it was in the MNI space, and I put 0, 0, and 0, it should be the anterior commissure. Okay, but it's not. Okay, so don't worry for that for the moment. So, and this second row is just the number of voxels. Okay. Okay. So that was for the anatomical scan. So normally you should all have an anatomical scan. So now you can add another image. So let's go again. Add file, add from file. So you go to the folder func or functional, and you select the first run, run 1. Okay. So now you have two images. Yeah, it's a kind of a mess. So here you will see two images that are listed. So you can click on the little eye of the anatomical. Oh, yeah. That is, it's not really good. Okay, and there is a minus sign if you want to remove the previous. So here I have 3 images like here. And if you want to remove the anatomical, because they are not in the same space, so it's why so you remove it, and I should be better. So now in this menu, you should get only one image. Okay, so everybody has the functional. As you can see, as compared to the anatomical, the resolution is lower. the size of the voxel is so I think where can I see that? Yeah, if you go there, there is a question mark or a Y letter here. You click on it, it gives you the description of the file. So the resolution, the number of yeah, the resolution, you have 64 slices by 64 by 40 slices in Z. It's 3 millimeter by 3 millimeter by 4 millimeter. Okay. And yes, the dimension 4 is the time. So it's a functional, it's an API sequence. So it's a time series. Okay. So to see that, so it's not, you can click on this movie button here. If you do that, yeah, you will see things moving, but as Neurodesk is not really happy with that, we'll stop it. I hope not someone is epileptic. So what you can do, yes, as I showed you, you have the location of the arrow, but you have also the volumes. So you can move volumes per volume. So if you do plus, okay, and so what you can see is the change of the signal in image as the time goes on. And so, yeah, you have 140 volumes. So we'll go over these 140 volumes. If you do it manually, then okay. We are good with the display. Okay. Data lab. So let's see if I explain everything. FSL to one bold. Okay. Okay, so let's start to process our data. Okay. Everybody is fine now? Yeah. Okay. So just minimize it. Don't close FSL like that. You can open it back. Okay. So I open another shell with the FSL in it. So I do by the GUI, functional imaging, FSL 16 to open a new shell. Okay. That's big. Yes, as you wish. So it's always, my desktop is a mess because I always keep them open. So I cannot find anything after a while, but yeah, you can close it, but as you wish. If you want to run parallel things, so if you want run one subject, another subject, you can open two shells and do it in two shells differently. So, but okay. So what we will use for preprocessing our data is fit from FSL again. So fit is capital F. So in FSL, there is a rule that when you put a capital, you will get the graphical interface. If you don't put the F, it will try to run the command line. Okay, so fit is FEAT. And it's not what I wanted to run. Okay, it's FSL. FSL. And okay, except this one. it's not capital. Okay. And it should open this menu. So FSL has different modules. So you can see all of them here. So there's the FSLIs here. You have FIC, the one we will use for fMRI analysis. But the first thing we will do is to use BET extraction. So BET stands for brain extraction tool. So you click on it. Should open a new window like that. Yes. No, sorry. So I will. It was my mistake. So I say fit, but I wanted to say FSL. So don't use fit for the moment. Just use FSL. So it opens a menu like that. And you click on bet.
Yeah.
Okay. We good? So just to explain you, so let's do it and I will explain you why we are doing it. So it's a brain extraction tool. It works on anatomical image, okay? So we are gonna select the T1 image we got from our subject. So you go back to the data set and the subject, you got the anatomical folder and you select the file, okay? You click on the here.
Okay.
Okay.
Yeah, it's still loading.
Okay, so you don't have it yet? And if I go to this, so I go to sub 05, anatomical, you should see two files now. So this one is the original one, sub 05 T1 weighted, okay? And this one is sub 05 T1 weighted gray. So let's check what he did. Okay, so I go back to FSLIs. Should get somewhere. Okay, so let's get rid of the functional for the moment. You go file, add from file. You go to anatomical, anat. So I'm gonna load both of them. So the raw data, let's put some, oh, and change can I do that? Can I do that? Yeah. Change to 800 to get better contrast. Okay. Add file, and you add the second image. Okay. So you don't see anything yet. Okay. This is normal. Everybody's okay now? So yeah, there is a two file. So now you can, if you click on the little eye here, so the second one, and you go back, so you see the raw data and you just switch between them. So you see what the brain extraction tool did. So yeah, you click on this little eye, the second file. Or if you want to look at another way, so you click on the brain image and you change the color. So as you can see, so that is the subject 5, but you can see it's doing a great job. But if you see, for example, at the orbital part of the frontal, or maybe mine is good, but you see we'll miss some spot here. It will not be perfect. So it's why you can tweak it with the options if you want better. For me, it will be enough. So the reason we did that is we are connecting the preprocessing using the T1 image. So what we will do, we will register the functional to the T1 brain image. So it's why I remove the skull, because I don't want the functional to be registered to something that doesn't exist in the functional image. So that is the reason why I'm doing it. Clack, clack. Okay, next step. So let's see who is in trouble. Who has issues? No? Still?
I'm restarting everything, so.
Okay.
it's download.
Yeah.
So when we save this, we don't get all the files, we have to do something.
Datalad get. So the first thing we did was datalad install. So that gives you all the skeleton of the data set, and datalad get and the folder you want. So sub 01 or sub 02, the one you want. It will download the data directly. Okay. So what we did was that. So install the data set, download the subject data after we did FSLIs.
We don't. Okay.
So now you can close the bet tool. So now get back to the FSL menu, and what we will open here is a fit. So this time you can open fit. Yeah, hopefully it will open. Yeah, so normally it should open this menu. Okay. Okay, so everybody's on this menu. So the first thing you go to this data part, data part. Not start, not presentation, you start with that. Okay. So what we're gonna do is a first level analysis, and you will change that full analysis to pre-processing. So you can click on it and pre-processing. It will not change a lot, but just we will do step by step. Okay, so now let's load the API images, the functional. So you go here, there is another menu here. You go again to work. What? I'm redoing. What? Again. So you go here, select 4D data. It will open a small window. And here you go on this folder, and you go back to the functional image. You go to work. That's it. Not here. Work. Let's select my subject 5. Functional. So let's take the first run. Okay. You click OK. And you click OK again. Okay. Now you should see that if it is correct, you should see 146 volumes here. The repetition time here, 2 seconds. Okay. So if it is loaded correctly, should show that. Okay for everyone? Okay. So there is a lot of menus. So we can do a lot of tweaking. So I will just go straightforward and do some tweaking, but not a lot. Okay. So follow me. So after that, you go to, so that is okay. You go to registration. And you can click on main structural image. You click on it. There is a new menu. Okay. So what is asking here is a structural image. The one we just created with BET. So the one which is extracted, the brain extracted one. So you go, you select the folder, you go back to the subject folder. Let's go back again. What? Not this one. So if I'm missing, okay, not that. Okay. You click OK, and it should appear in the blank part here. Everybody's loading the proper images? Yeah? Okay, look, so let's change some options and I will show you why. So you have normal search here. We'll change to full search. Both of them. Full search for both of them. We'll get back to that. And instead of BBR, we select 12 degree of freedom, 12 DOS. So for both of them, okay? Okay. So you do, for the registration, you do full search for the structural and for the standard one, the standard space and for the structural image. And you change to 12 degree of freedom for both options. So for here and here, you select 12, 12, and full search, full search. Okay, so if we go back to data, there is a spot where you can put the output directory. So you can select the one you want, or you can write, for example, for me, I will put sub 05 run 1. Okay, so you can put whatever. It will write in your, if you want to write it in a specific location, you go in the folder icon and you select well. But or you can put a name and it will write it in your home directory. Okay, that's okay. So everybody's okay? Okay, so data, so the tabulation, the data we did. So you select the data, you change the name of the output directory. We did the registration, so not yet, but we will do. So we change the options here. Last thing, do I need to change something? Yeah, yes, we will change something. So if you go to the prestat tabulation, so there is a lot of options here, but just for the sake of the tutorial, we will change that to 10. The spatial smoothing, the smoothing of the data. So 10 millimeters is a big smoothing filter, but we will go. I will explain why. And I think that's it.
If you put your own name on the output directory, where does it mean relevant?
The working directory is a home folder. So it will, yeah, basically everything will be put in your home folder, which is home, which is that. Yeah, you don't see it here, but it's in the, not the root folder, but homes. Yeah.
Does the spatial smoothing
It's a smoothing. So it will, yeah, I will go. So why with, so I want to run it first and I will explain all the options we selected. Okay. Okay. On what? No, nothing. Don't change anything here. So data, it's look like that. So you loaded the data, you put the output directory folder. Prestat, we just changed the smoothing. Okay. And registration, we changed it to get a structural image, and we changed some options here. Okay. So if you're good with that, at the end, you click go. So let's get back to what we did. Okay. Okay. Loading the data, preprocessing. Yes, let's. So if you want to get back to why we did all these steps, so again, you go to this tutorial, you will see a lot of explanation why and how to tweak, for example, for bet. There is different option you can use. So there is different chapter. Yeah, so we did the brand extraction tool. And so let's see what we did. So the fit. Again, also everything is explained how to do it. if you are confused, you can see there is even videos how to do it. So yeah, it explains everything. So it's really, really well done. Okay. Motion correction. So so there is a lot of options. So the one we did, so if I go back here, when it's running, if I go back to Fit, in Prestat, yes.
If I go to tells me to set up
The what? So last thing. We changed that for pre-processing.
Oh, sorry.
That was a
Yeah.
good catch. Good catch. I forgot that. Before to run it and not run it, this pre-processing part. So just to explain you the McFlirt option here, the motion correction. So it's, as I said, it's time series. So it's 140 volumes. It takes, I don't know, maybe 10 minutes. So the subject can move, few minutes, not 10 minutes, a few minutes. The subject can move during the scan. So each volume needs to be registered to the first one or the middle one, but all images need to be registered correct for this motion. So that is part of the preprocessing you are doing. So we are using McFlirt, which is a software by FSL, which will do rigid registration. So what it does, so there is nice, so yeah, you can do that with, you have one image, another image. What you want to do is to have the two images to be registered spatially. So yes, what you do with rigid body transformation is just, yeah, your image, if it is a little bit on the right, you need to move back. So you will do 9-degree of freedom. The 9-degree of freedom is 3 translation, 3 rotation, and 3 translation. Like 6. And yeah, so you will move X, Y, Z, and everything needs to be registered together. For the as-seen registration. So the motion correction, as it's the same subject, normally the brain doesn't move, doesn't change. You don't need a very advanced normalization. You just need to register it because the volume is the same. So you don't need very precise normalization or warping of the image. Okay, so that is a McFlirt. Slice timing correction. So I will skip this one if you want to read about it. It's pretty important, but yeah, for the sake of time. And we didn't run it, okay? So there was a question about the smoothing, pretty interesting. So in new imaging, starting with the functional structural, we smooth everything. The idea behind this is, so we have noisy data. So the best to increase the signal is to smooth. Okay. The more you smooth, the more signal and the less noise you get. The only problem is the resolution of your. So as I showed you, the API data are 3 by 3 by 4. And if you do smoothing, you will lose the resolution of your image. So it's a balance between the resolution you want and the signal you want. So yeah, there is different kernel, what they call, they smooth at different size. And here it's 10 millimeters. So you see, you lose a lot of the resolution. So here I did 10, which is pretty big. But as we are doing single subject, I want to get the most of the signal I can get. Okay. Okay. So that is the smoothing. So we did 10. So yeah, at the end we did registration. So what we did, so what you can do, you can take your functional image and to register it to the MNI space. Okay, you take one image, you take API template in the MNI space. But as this data set has also structural, what we did first registration of the API to the T1 image, to the brain T1. So that's the first step. And after we use the T1 to register to MNI space. And the reason why we do that, because the structural has a better resolution So it's one by one by one. So the registration will be more refined as compared to directly register the API to the MNI space. Okay. Okay, so that is a summary of the different transformation, the 12 degree. So you have translation, rotation, zoom, and shear. Okay, so 3 by 3 by 3 by 3, 12. And the shears start to a little bit change the shape of the brain. So it's why we didn't want to do it for the motion correction, because there's no need. Okay, it's the same brain, the same volume. Okay, and those, yeah, you register to the structural, to the template, doing the translation, rotation, zoom, scaling, and shears. Okay, so it's 12, 3 by 3 by 3 by 3. So I was talking about smoothing. Another reason to smooth, because there is also there is a statistical reason. You want to statistical or signal reason. You want to increase the signal, so you smooth. Another thing is that when you register to a template, the more you smooth, the more it will be easy to register your image. So sometimes, and yeah. So there is these two reasons why you smooth. And there is this rule of thumb, yeah, so the amount of smoothing is depend on the amount or the size of the signal you want to get. So if you expect to have a large effect, you can increase the smooth, yeah, 12, 14. If it is small, you need to keep your smoothing kernel very low. Okay, but that is a rule of thumb. So people at the beginning were using 14, now we are using 8. Depends. Okay, so we did registration, and here's the video. So what you did exactly. So if you want to do it again, and normally, okay, it's 3:30. Do you want to do a little break before we continue?